In this session, we're going to talk about chemical bonding. In other sessions, we're going to talk about Lewis structures. We're also going to talk about how to find the formal charge of a compound. So now, what is bonding, or what is a chemical bond? So now, the coming together of two or more atoms together is called chemical bonding. Let's say you've got this element or substance and that element, and when these ones combine, they give you a substance, another substance. Let's say after these ones combine, and this is how they look. This will be called a bond. They've formed a bond. Okay, so now you have to understand that there are about two main types of chemical bonding. Okay, now you have to know these two types. Okay, so you can have what we call, ionic bonds, ionic bonding, or ionic bond. Let me say ionic bonding. Then you can have what we call non-ionic bonding. Okay, now non-ionic bondings, these ones have got like a lot there, hydrophobic, hydrogen bonds, van der Waals. Those ones are a lot of bonds. Okay, but now the ones that you're going to talk about in this, in your session, or let me say in your course, you have to talk mostly about covalent bonds. Okay, you have to know covalent bonds. Okay, in your chemistry sessions. Now, these covalent bonds, there are about three types of covalent bonds. Okay, they are what we call polar covalent bonds, they are what we call non-polar covalent bonds, and they are what we call a coordinate covalent bond. So that's what we're going to talk about in this session. Okay, so let's talk about each of these bonds one by one. Let's start with ionic. So what is ionic bonding? So ionic bondings, what you should know about ionic bonding, one is that ionic bonding is a kind of bonding that happens between a metal and a non-metal. Okay, it's usually between a metal and a non-metal. Okay, now what happens? There is transfer of electrons. Okay, there is transfer of electrons. Now that is a very, very big point for you to know. So in ionic bonding, electrons are transferred probably from a metal to between these ones. Now what happens? Metals themselves, they tend to lose electrons. That is a very important point for you to know. Then non-metals, they are fond of gaining electrons. Okay, so examples of metals that we can talk about, you can talk about magnesium, sodium, metals like that. Then non-metals, you're talking about things like oxygen, you're talking about things like fluorine, anything that is a non-metal. Okay, so you find that metals themselves, they tend to lose electrons. And when you lose something that is negative, what do you become? When you lose what is negative, what do you become? You become positive, right? Okay, then non-metals themselves, they tend to gain electrons. Now when you gain something that is negative, you become negative. Okay, so these will be the charges. Now if you look at your periodic table, just as a reminder, if you look at your periodic table, this, let me say this is our periodic table. Okay, so let's say this is, you know, your hydrogen and you know, your helium, like that. Now you find that there's a zigzag that we draw on the periodic table like that. So the way we are going to differentiate these ones in this region, they are non-metals. Then the rest, what remains, the rest, these ones are metals. So you're able to see that on the periodic table you have more metals than you have non-metals. Okay, so that's what you should understand. Okay, now what happens now when you react a metal and a non-metal? Allow me to rub here. Okay, what happens when you react a metal and a non-metal? Okay, let's use the same analogy that we said. Like if you say a metal, in this case we get magnesium, we are reacting it with the fluorine. Okay, now when you are reacting metals with non-metals, you are supposed to consider what we call valency. Okay, now there's what we call valency or valency and valence electrons. Now you should be able to identify, to distinguish these two. Valence, when you're talking about valency, this is just the combining power of an element. Combining power of an element. Valence electrons, those are the electrons that are found in the outermost shell. So you must be able to understand that. So for valence, when you're talking about valence, you know, the valence of an element is in the group in which it is found. Okay, so when you're finding the valence, just go in the group in which that element is found. For example, magnesium is found in group 2. Okay, that is you know, the valence. That is the valence, the valence. Okay, the valence of an element is found by that. So I find that if you're going to get, let's say for magnesium, this is in group 2, fluorine is in group 7. Okay, let me use these two terms. So I find that valence electrons is the number of electrons that are found in the outermost shell. Okay, chlorine has 7 electrons in its outermost shell. Okay, so it just needs to gain 1 for it to become stable. Those 7 electrons are called valence electrons. Now valence, we said it's the valency, we said it is the combining power of an element. So for valency, the way we're going to find valency, elements that are below 5, like in terms of the group, in terms of grouping, elements that are below group number 5, you just get the same number. Let's say if I get carbon is in group 4. Carbon is in group 4. So the valence, the combining power of carbon will be like 4. Okay, then the valency will be 4. But in terms of the valence electrons, yes, the valence electrons are 4, but for you to find the combining power, you are just going to get that. But for elements that are above, in group maybe 5 and above, for you to find the combining power of that element, you are going to say 8 minus the group number in which it is found. Okay, the group number in which it is found. Like for example, chlorine is found in group number 7. Okay, and it has 8 valence electrons. So what you are going to do, the combining power of chlorine, the combining power of fluorine, so you're going to subtract that, and you're just going to have a 1. Okay, so it means you only have one, you only want 1 electron for chlorine to be stable. Okay, so what am I saying? Valence electrons, they will help you. Valence electrons they will help you determine the group. You just, for you to find the valence electrons, just grow in the group number, okay, in which group that element is. Then there's, on the periodic table, we also got what we call periods. Now the way I find periods, you find periods by the number of shells, the number of shells that atom has. Now this is very key. So now let's solve some questions. We said magnesium, okay, and we said fluorine. Okay, we said fluorine is in group 7. Since chlorine is in group 7, it has 7 electrons in its outermost shell, okay, and that's the group number that it is found. Those are valence electrons. But now, what is the combining power of fluorine? You're going to subtract 8 minus 7 because it is in group 7 and it's above 5. So chlorine has a combining power of 1. Then let's look at magnesium. Magnesium is in group 2. Magnesium is in group 2. Since it is in group 2 is less than 5. So you're not going to subtract, you're just going to get the way it is. So the combining power of magnesium is 2. So now what do? What you are going to do, you are going to swap, okay, swapping of valences, okay. So you swap that. So you swap like that. At the end of the day, the molecule that you are going to have is Mg, okay. Initially the one is supposed to come here, okay, because you swapped the valences. Then you have fluorine, then you have your 2 like that, okay. So therefore the final molecule just be Mg. I'll not write the 1, okay, F2. So this is, you know, these elements have bonded, so that's how the bonding occurs, okay. So you have to understand that. Then for chemical bonding, you also have to understand how you do with what we call radicals. Now a radical is just basically a group of atoms with the same valency. Let me say SO4, okay, 2 minus. Why is it 2 minus? It's because sulfur and oxygen, these ones are in the same, they're in the same group. Sulfur is in group 6, oxygen is also in group 6, okay. So if we subtract from 8, the combining power will be 2, okay. But now these are non-metals, so they tend to gain electrons, so that's why you see the negative there. So because they are in the same group and they have the same valencies, they are called radicals, okay. So now how do you know bond ionically radicals? Let's say this is reacting with let's say aluminium. Aluminium is in group what? Aluminium is a metal, yes, but in which group is it going to be? Aluminium is in group 5, right? So on your periodic table, aluminium is in group 5. So the combining power will be what? 8 minus 5, that is 3. But now aluminium is a metal. What did you say metals tend to do? They tend to lose electrons. So because it loses, you have more positive charges like that. So now what do? You swap again. But now when you're writing, when you're writing your ionic bond, always start with the one that, let me just say, always start with metals, okay? Or let me say the ones that are positively charged, okay? So again, you're going to swap the way we swapped your valency for this one, the valency, and the valency for the other one. So what you're going to have in the end is SO4, okay? Oh, we said you are going to start with the one that is positively charged. So you're going to say aluminium, okay? Aluminium, so there's a 2, so the 2 come there, right? Then what about the SO4? SO4, there is a 3, so you're going to put this whole compound by 3. So this is how you bond, and this is how they react. So that's what you need to know about ionic bonds. Then we've also said another type of bond is those ones which are non-ionic bonding. Okay, now we said there are a lot, but we said we're just going to concentrate on what they are going to examine you on and what you just learn in your sessions. Covalent bonds. Now, what do you need to know about covalent bonds? What you need to understand is that first and foremost, covalent bonds happen between, these bonds tend to happen, the bonds between non-metals. Okay, so how do they do that? By sharing of electrons. Okay, so non-metals will share electrons. Okay, so let's take for example, let's say you have carbon. Let me say you have carbon and oxygen. Okay, in what group is carbon found? Carbon is found in group 4. Because it's found in group 4, 4 is less than 5, so it means the valency for carbon will just be 4. Then oxygen is found in group 6. The valence for oxygen will be what? It will be 8 minus 6, which is a 2. Then we have to swap these ones for us to make the bond. So we have C. Alright, when we combine these ones, so your 2 will come here because we've cross multiply, and your 4 will come there. Now you can simplify this one further, where you're going to say C or 2. Okay, so this, they are going, when you mix your carbon and your oxygen, you're going to get your carbon dioxide, and that's how the conversions happen. Other covalent bonds that you can talk about is when you have hydrogen gas, like that, hydrogen gas, carbon monoxide, water, there'll be covalent bonds there. Okay, so that's what I'm talking about. So you need to understand that. Then we've said that there are about three types of covalent bonds that you need to understand. Okay, so we said you have to understand what we call polar covalent. You have to understand what we call B. Let me say B. You have to understand non-polar, and you also have to understand what we call coordinate or coordinate. Okay, now coordinate. Let's start with polar. Now, what are polar covalent bonds? Okay, so in polar covalent bonds we have an equal, others will say an even sharing. Okay, so there's an even sharing of electrons. So in polar covalent types of bonds, electrons are not shared equally. Okay, electrons will not be shared equally. The most electronegative atom will have a partial charge. Okay, let's say for example you are reacting carbon and oxygen. Now what you should understand is that because oxygen is more, let me say something first. So I've introduced the aspect of electronegativity. Okay, so the electronegativity for polar covalent bond, it will be greater than or equal to 0.5. There's a table in Zoomda about this, but you don't need to master the table, but you just have to know if after you calculate the bonds and you find that your answer is greater than 0.05 or 0.5, then the bond is polar. So if I've got carbon dioxide, if I've got carbon is reacting with an oxygen. Okay, when these two are reacting, what will happen is that oxygen will pull electrons in the bond towards itself. Okay, but now it's not going to pull all the electrons, but it's just going to pull them because it is more electronegative than the other element. So therefore it is going to have a partial negative charge. Then this other one, because other electrons have been pushed, is going to be like, it act as if it is deficient of electrons, so it will have a partial positive charge. Okay, now what has just happened here, we are going to see that this is a pole. There's like, it's like a positive pole, right? And this is like a negative pole. So because there are two poles, this is called a dipole. Why? It has two poles, right? So it's called a dipole. Okay, so two poles, so that's what I'm talking about. And the way I've drawn the arrow, that's how we show the dipole of a molecule like that. So it is very important that you understand this concept. Very important for you to understand. Okay, then when we're talking about non-polar compounds, these ones, there is equal sharing. Equal sharing of electrons. Okay, so common examples that I can give is maybe C and H. Okay, C and H, these ones, there's like I may say there's equal sharing of electrons between, because for non-metals or non-polar compounds, actually, the electronegativity, the change in electronegativity, is less than 0.5. So the electronegativity for carbon and oxygen, when you check on your, in the zoomed table there, you're going to realize that they just are so close to the point that there's no difference. So because of that, they are just sharing, electrons equally. Other examples that you can give are diatomic molecules. For example, if you've got oxygen is, is reacting with another oxygen. Oxygen is O2, right? So because all of them, they are fighting for those electrons. So if this one pulls, if it pulls 20, even the other one also put 20, because they've got the same electronegativity. So at the end of the day, there will be no net. The net will just be 0. So because of that, they'll just share electrons equally. Okay, same with other diatomic molecules like hydrogen. Okay, hydrogen molecule can also talk about nitrogen. Nitrogen tends to form 3 bonds, right? So what am I talking about? O2, H2, N2. Okay, so that's how these bonds are formed. Okay, then let me mention something very clear. So about electronegativity, let's say this is our periodic table. Okay, so if this is our periodic table, okay, so that is your hydrogen and that is like your helium. Okay, so now what happens is, let's say the most electronegative atom that you're going to find or element on the periodic table is fluorine. Okay, so electronegativity is just the ability of an atom to pull electrons towards itself in a bond. Okay, simple terms, we can just say, because we are saying it's electronegativity. So what you are able to see is just electron negative. Okay, so in simpler terms, we're just talking about those electrons which are elements which are electron negative. They want the negatives. Okay, so what do we have? How do we represent? So the way electronegativity trends are going to move on the periodic table, you are going to move towards the fluorine, which is the highest. Okay, then in this region you're going to be moving like that towards the fluorine again. Then in the other direction you're going to be moving like this towards the fluorine again. So as you move to the most electronegative element, fluorine, the electronegativity tends to increase. That's the point that I'm trying to drive across. Okay, now let's talk about the last part, what we call coordinate covalent bond or covalent bonding. Now what do we mean when we talk about coordinate covalent bond? Okay, so in a coordinate covalent bond, we have a lone pair of electrons, okay, from one compound sharing to another. Okay, what do I mean here? Let me say this is ammonia. Okay, ammonia is reacting, let's say, with boron trifluoride. Okay, then this our ammonia, it happens to have a lone pair of electrons. Okay, so what will happen is that when the bond is being formed, yes, we will have our ammonia, but now our ammonia in this case, after the bond has been formed, it has donated those electrons to the boron, fluoride. Okay, so no, it has not donated, it has like shared to the because we're talking about sharing in covalent bonds. So I find that there's a sharing of a lone pair of one element to another. Okay, so because of that, you find that that's why it's called coordinate. That's the only difference. Okay, there's no equal sharing. Okay, so that's about coordinate bonding. So that's where we're going to end from this session. See you in the next session where we're going to be talking about Lewis structures.